Okay, so as I was saying, we are taking the course statistics 205, and basically, how things are being done. Some objective questions are written on the whiteboard, and students are expected to provide answers to these questions. For those of us who haven't gotten the keynotes, all right, calculation is a keynote for it, theory is a keynote for it. There are two sides. Just ensure to reach out to me on www.tutorial.net after the class and send me direct message using the WhatsApp button on the top right hand corner. And come next semester, join the private classes early as you can so you can start taking your classes without further ado. Things are being done. Let's get straight into tonight's class. Okay. Now, we have the course STT205. Okay. You can see the comment section is a little bit busy. All right. So let's start with the theory and then we go to the calculation. So let's take a couple of questions. It's really been a very busy, stressful day. Been very, 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 I feel very exhausted already, but we just have to make something out of it. And taking a couple of questions. I think the majority of us have done the needful, especially those in the private class. You have been given all the resources you need and everything at your disposal. Yes, thank you very much. Good evening, you're all welcome. So let's just go straight into it. So to start with, the very first question we're having today, okay, we have question 1. Now it says, a symmetric distribution has a peak at the dash of the distribution. A symmetric distribution has a peak. A symmetry distribution has a peak at the dash of the distribution. A symmetry of a distribution has a peak at the dash of the distribution. Okay. We have that as our first question. Awesome. Middle. Thank you very much for that. Wonderful. Yes. At the middle. Okay. Awesome. At the middle. Now we have question 2. It says median and mode are measures of dash tendency. Median and mode are measures of dash tendency. Median and mode are measures of dash tendency. Wonderful. Thank you very much for that, Miss Justina. It's been a while. Trust you are good, ma. How are your exams going? Center. Yes, central tendency. Okay. Excuse me. Yes, thank you very much for that. Central. Central tendency. We have question 3. Excuse me. Question 3 says, the direction of the scale depends on the relationship of the peak of the distribution of the central of the dash. The direction of the scale depends on the direction scale depends on the relationship, okay, of the peak of the distribution of the peak of the distribution to the central, of the dash. The direction of the scale depends on the relationship of the peak of the distribution central of the dash. Wonderful. Histogram. Yes. Histogram. Thank you very much for that. Central of the histogram. Okay. We have question 4. Thank you very much for that. Question 4 says, dash is a single value computed from the set of data that measure the central item of the data. Dash is a single value dash is a single value computed from the set of data that measure the central item in the data. Dash is a single value computed from the set of data that measures the central item in the data. Wonderful. Median. Thank you for the attempt, though. Not mean. It is median. Okay? It is median and not mean. We have that as median. Okay. I think it's stable now. Yes. Now let's take question 5. Question 5 says, Dash is used to solve problems involving set theory. Dash is used to solve problems involving set theories. Wonderful. Dash is used to solve problems involving set theories. Yes. Wonderful. Venn diagram. We have that as Venula in full, but in short it's called Venn diagram. Okay. Yes. Thank you very much for that. Let's just abbreviate that Venn diagram. Can we accommodate one more question here? Yes, I think we may. Now let's say it says this: A and B are equal if and only if they contain the same dash. A and B are equal if and only if they contain the same dash. Only if and only if they contain the same dash. Wonderful. So let's just stop at 5 questions. 6 questions. We've done a lot already on this course. We've done a lot already on this course, so there's really nothing much, there's really nothing new to do. So let's head straight to calculations. And even the calculations, not so much on the calculations as well. So we're just going to touch some things here and there very quickly so that and like I said from the beginning of the video, for those of us who haven't gotten the proper lecture on this course, all you need to do is just reach out to me after this class this night so I can send it to you. All right. So let's just stop here for this theory and let's go straight to the calculation. I'm just trying to push this. So exhausted right now. But just trying to push this. So now I'm going to raise the board and we can. And for those of us who haven't gotten the keynotes, like I said earlier, it's very, very important. Let's ensure to request. So very quickly, we're going to be starting with what it means by median. All right, just a moment. At this point, you might want to get your calculator. Okay. So at this point, you might want to get your calculator. Okay. So the first thing we want to talk about, something I noticed that we haven't done much, we have not done much on it, is called GM. All right. GM, which is geometric mean. Okay. And there's a simple formula for GM. The simple formula for GM is the square root, okay, the square root of n. Then we have x1, are we together, comma, x2, comma, x3, and till xn, more like till, all right, the total final number. That is for GN. Very simple, precise, and straightforward. Now, let's say, for example, we are instructed to find the GM for 3, 5, 6. All right. Find the GN for 3, 5, 6. Simple and precise. Okay. Simple and precise. What is the N of this data? How do we find out the N? If this is the formula. What is the X1? What is the X2? And what is the X3? Very simple. Can everybody tell us what is the N? Can anybody tell us what is the N? Can anybody tell us? Okay, not bad. Not bad. Wonderful, wonderful. Lovely, lovely, lovely. Yes, you're absolutely correct. Absolutely correct. How did we arrive at that? Look at it. Our N is 3 because we have just 3, let's say, elements. All right. So 1, 2, 3. That's our N. So our N is 3. Our X1 is also 3. Our S2 is 5. And our S3 is 6. So we have 3, okay? We have the square root. Are we together? Then what's next? Wonderful. Then what next? We have, this should be 3 multiplied, all right, by 5 multiplied by 6, all right? So let's have that. So what is the multiplication of all this? You know, I said you need to get a calculator. It's where you need to use a calculator. Okay. Is anybody helping us with that? Thank you very much. We have 90. So what's the square root of 90? Wonderful, wonderful. Awesome, awesome. I can see we are getting it. So let's get our calculators working. Okay. So what's the square root of 6? What's the square root of the 90? Wonderful, wonderful, yes. So you can just do it this way. From what I have here directly, all right, you have 3, then you have the square root of 90. So this is what you should be getting. So you should be getting something like this. 28.5. When you put 3, then the root of 90, you should be getting 28.5. Okay? So that is that 2 geometric mean. And likewise, we have harmonic mean. Okay? Likewise, we have harmonic mean. For harmonic mean, these are the things that I feel we are not really in the class. The formula is a bit different. For harmonic mean, we have n over 1 over x1, comma, or we can use plus instead. All right. We also have 1 over x2, and it continues like that. 1 over x3 till we have 1 over xn. Okay, so now the same example, 3, 5, and 6. All right, so find the HM for 3, 5, 6. The same procedure. What do we need to do? We already know our n. Our n is 3. All right, we have 1 over our x1 is 3 plus 1 over x1 is 5 plus 1 over x1 is 6. From here, we have 1 divided by 3. Okay. We should be having 0.3 plus 0.2 plus 0. Let's just say that 1/6. From here, it's very easy. Wonderful. So from here, we can just say all these added together will give us what? We have 0.3 plus 0.2 plus 0.16. 0.66. Then when you do this, 3 divided by 0.66, we have in 4.54. And basically, that is all on harmonic mean. These are the things I know that we've not really touched, we've not really done much on. and start to me pertaining a question. Okay, so let's quickly take that question and we can call it a wrap for tonight. And like I said, for those of us who have missed the past calculation classes we have done, just reach out to me after the class tonight. So there's something called factorials. When we say factorials, we have, let's for example, we have 5 factorial. 5 factorial will give us, when we say 5 factorial, we are simply talking about 5 multiplied by 4 by 3 by 2 by 1, or 1 multiplied by 2 by 3 by 4 by 5. Either way, if you do this, you get the same answer. If you do this, you get the same answer. Okay? Are we together? So for example now, if you are not giving 4 factorial, there's no need for you to do 5 times 4 times 3 times. No. What you just need to do is 5 times 4 factorial. Why? Because you already have 4 factorials here. The answer for 4 factorial is what you have to multiply by 5 and get 4 factorial. It's the same procedure. Okay? Or you are giving 3 factorial. I beg your pardon. This will be, if you are giving 4 factorial, to be 4 multiplied by 3 factorial. If you are giving 3 factorial, it will be 3 multiplied by 2 factorial. Since you already have for 3 factorial, and for this you already have for 2 factorial. Okay? It is basically what it is. And there's something called permutation. In line with this factorial, there's something called permutation. When we say permutation, we are simply talking about, a very good example of that is 15 permutation 3. Very simple. How do you solve this? 15 becomes 15 factorial all over 15 factorial all over open bracket 15 minus 3 close bracket factorial. Meaning that the formula for this, all right, the formula for this is n factorial open bracket n minus n minus r factorial. And by the time you already have 15 times 14 times 13, let's assume that this is 10. Okay? Let's assume that this is 10. So by the time you get to 14, 13, 12, you have 11, you are stopping at 10 factorial. Why? Because you already have 15 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay? So the answer you get from here, you multiply by the answer you get from here. Okay? Don't forget that this will be minus. That's the sign. Minus. Okay? And from here, you can do the required. So nothing much. Okay. And in line with this is a permutation. In line with this, we also have combination, factorial, permutation, and we also have combination. Now, for combination, there's a formula for combination. All right. Combination says n factorial all over r factorial into bracket n minus r. Okay. And we have factorial. Different formula. Okay. So let's say you get question like 3 and 2. So from this, n is 3 factorial. All right. Your 2 is r. All right. So we have 2 factorial. And we have 3 minus 2 then. And from this, your work is done. So like I said earlier, it's not going to be a long one. We've done everything in the class, and I believe everybody in the private class have access to all these classes. So you want the detailed explanation of all these calculations only. Now we have theory, we have calculations. You want the detailed explanation of only the calculations. Just request from me after this revision class. Thank you very much, everyone. I wish you all the best and success in exams tomorrow. And next semester, let's try to be, all right? Let's ensure to join the private class as early as possible. This will enable us to take a lot of things without rushing. You have a wonderful evening and bye for now. Bye.